Good morning everyone. My name is Muskan Kumari. My roll number is 205008 and today I am going to present on the topic graph theory of discrete mathematics. So what is a graph? A graph G is a mathematical structure consisting of two sets V and E, where V is a non-empty set of vertices and E is a non-empty set of edges, as you can see in the figure. For the figure 1, V1 and V2 are the vertices and E1 is the edge. Now coming on to the basic terminology, trivial graph. A graph consisting only one vertex and no edge is called a trivial graph, as you can see in the example. Second is null graph. A graph consisting n vertices and no edge is called null graph, as you can see in the figure. Directed graph. A graph consists the direction of edges, then this is called directed graph. So here is the diagram for directed graphs. Fourth is undirected graph. As the name suggests, a graph which is not directed is undirected graph. Fifth is self loop in a graph. If edge having the same vertex as both its n vertices is called self loop, as you can see in the example. For the first figure, V1 is the vertex and E1 is the edge which is starting and ending at V1. So for E1, end and start vertices both are V1, so it is a self loop. Now the sixth is proper edge. So an edge which is not a self loop is called a proper edge. Now seventh is multi edge. A collection of two or more edges having identical endpoint is called multi edge. Eighth is simple graph. A graph does not contain any self loop and multi-edge is called a simple graph. As you can see in the figure, there are three vertices V1, V2 and V3 and three edges E1, E2, E3, each connecting between two vertices. Now the ninth one is multi-graph. So a graph that does not contain self loop but contain multi-edge is called multi-graph. As you can see in the figure, the left hand side portion is a simple graph but the right hand portion is a multi-graph. Is a multi-edge structure, so it is a multi-graph. Now the tenth one is pseudograph. A graph contain both self loop and multi-edge is called pseudograph. So as you can see, there are simple graph, self loop and multi-edge both in this figure, so it is a pseudograph. Now coming on to incidence and adjacency. Let EK be an edge joining two vertices Vi and Vj, then EK is said to be incident of Vi and Vj. Two vertices are said to be adjacent if there exists an edge joining these vertices. So if V1 and V2 are the two vertices and if E1 joins V1 and V2, then V1 and V2 will be said to be adjacent. Now coming on to degree of vertex. The degree of vertex V in a graph G written as TV is equal to number of edges which are incident on V with self loop counted twice. For example, this is the figure and here we have to count the degree of vertex for each vertex. So for V1, there are two edges on its left, on its right, one going towards V2 and other going towards V4 and a self loop. So the two edges will count 1 plus 1 and the self loop will count plus 2, so which is equal to 4. So degree of V2 is 4. So degree of V1 is 4. Now for V2, there are only two edges, one is going towards V1 and other is going towards V3. So degree of V2 is 2. Degree of V3 is also 2, as it has two edges, one going towards V2 and other going towards V4. Now for V4, there are three edges, one going towards V1, other going towards V3 and last one going towards V5. So the degree of vertex for V4 is 3. Degree of V5 is 2, as you can see. Degree of V6 is also 2, as you can see. For V7, there is only one edge which is going towards V6, so degree of V7 is 1 and degree of V8 is 0. Now coming on to isolated vertex and pendant vertex. A vertex having 0 degree is called isolated vertex and a vertex having 1 degree is called pendant vertex. Finite and infinite graph. So a graph with finite number of vertices as well as edge is called finite graph, otherwise it is called infinite graph. As you can see, the first one is finite graph and the other one is infinite graph. As in first one there are finite number of vertices and in second one there are infinite number of vertices. Now coming on to the question, it is asking which of the following is true for the given graph. Graph is given and the options are degree of P6 is 3, degree of P1 is 2, degree of P6 is 2 and degree of P2 is 1. Let's see. Firstly for P6, as you can see in P6 there is one edge which is extended towards P1 and there is self loop for P6. So the self loop will constitute plus 2 and that edge will constitute plus 1, which is equal to 3. So degree of P6 is 3. So option A is correct. And since option A is correct and degree of P6 is 3, option B is incorrect, that is degree of P6 is 2 is incorrect. Now coming on to P1, so there are two edges subtended from P1. One is going towards P4 and other is going towards P6. So degree of P1 is 2. So option C is also correct. Now coming on to P2. So for P2 we have no edges. So degree of P2 is 0. That is P2 is an isolated vertex, not a pendant vertex. So option D is incorrect. Now question 2 is asking number of isolated vertex in following graph. As you can see, each vertex other than V7 has one or more edges subtending from it. So V7 is the only vertex which has no edges or whose degree is 0, and isolated vertex are those vertices whose degree of vertex is 0. So for this question the answer is 1, that there is only one isolated vertex which is V7.